Hello again. This is going to be our second video on equations. So the first video from section 6.2 was more basic one or two step equations. In this video, we're going to specifically be talking about equations that have variables on both sides. There's going to be a little bit more distribution, more combining like terms to deal with. And the fun part for everybody is we're going to be dealing with equations that have fractions. Um, that's usually a messy thing to cover. And we'll also do maybe one with decimals. Um, once we get to there, it should be pretty straightforward. So let's jump into the notes. And so I'm still, if you're following along from the lecture outlines, I'm on the second page now of those lecture notes for 6.2. We're docking the camera and we'll get going on equations. All right. Let's start with 21. Everything before 21 was covered in the previous video, so you need to go back and review that. And so what do we do when we have variables on both sides? How do we isolate the variable? Uh, in the long run, it does not matter if you get the variable to the left or the variable to the right. I know a lot of people are just like, we want x equals, so we're always going to get x to the left, and that's fine. That way you're consistently doing the same steps every single time. You could also, sometimes what I'll do is I'll get it to the right because, that I want that coefficient on the variable to be positive if I can. Just that's one. If it's negative, that's one more thing you have to deal with. And we'll get into inequalities that can be helpful if we have positive coefficients, but in the long run, it does not matter which side you get it to. If two people are working it on different sides, in the middle, what will happen is like all your signs will be backwards from somebody else, but in the end, we will get the same exact answer. Okay. But it's important to know like where you're trying to go. That helps you know what to do next. All right, so 8x minus 10 equals 3x plus 5. Well, I'm going to get the variable to the left because that's the more common. So now the question is, what do we do when we have variables on both sides? Well, if we're getting variable on the left, what I look at, what I think of when I see this is that 8 we're going to have to do something with, that 9 we're going to do something with, that 5x needs to get moved over here. The two things I'm not going to move in this problem is that x is going to stay on this side, that 24 is going to stay on this side. It's not going to stay 24, but that number is going to stay over there. Okay. So um, it does not matter when you start moving your constant terms and your variable terms, which one you move first in the long run. I do prefer to move the variable terms first. Um, if this was in college algebra, I think I'd probably go into more detail why. Just sometimes it's a little bit of advantage, but for us with the more basic equations, I think it'll probably be okay. So let's say, we're getting a variable on the left. So I want the variable over here. So what do we do with that 5x? So what you don't want to do is, and again, I'll let MATLAB do a little bit more skill. So I want to talk about some of the common mistakes is you don't want to do this. You don't want to divide by 5. First of all, it's going to be wrong because you didn't divide everything by 5 and you're still making fractions, which again is another reason why I said, if you're going to divide, do it last. But here's the real reason why we don't want to do this. Did that move that x over to the left-hand side? It dealt with 5, but it did not deal with the x. So that's all it's doing over here is leaving us with x plus 24, which actually should be 24 over 5, but yeah, so again, if you're trying to divide when you're solving an equation, for our equations, that should be the last step. So we don't want to do that. So what is the correct way to do this? All right, so if you're moving in entire terms, in this case, the 9 or the 5x across the equal sign, you're always going to do add or subtract. So since this is a plus 5x, we're going to subtract 5x from both sides. And when you do this, please don't just put minus 5. It's 5x minus 5. Those are unlike terms. You should not be abstracting those. So if you mean minus 5x, please put minus 5x. That'll make me happy. And then what we do to one side, we have to do the other. So we do our x's with our x's. And so 5x minus 5x is 0. It's 0x technically, but 0 times x is 0. And that's the whole reason we did that was to get rid of it on that right-hand side. So then we get 3x plus 9 is 24. And if you've went through the first homework on this in the first video, now we're right back to equations that we've been solving multiple times. And so we're still trying to get x by itself. So next thing we do is subtract 9 from both sides. And we get 3x equals 15. And then the very last step is 3x means 3 times x. We're going to divide both sides by 3. And our answer is x equals 5. So compared to what we've been doing, this is sort of the level that we were at towards the end of last homework, the last video. Now we're basically just adding one more step, right? And so this is why, again, make the conscious decision on which side you want the variable on. That will control what's moving where. Okay. So now let's do another one. Now for this one, I want to move it to the right-hand side just to show you what happens. So for 23, we have 8 times y plus 2 equals 10y plus 16. Okay. All right, so what do we do first? Well, hopefully you're looking at that parentheses and saying, no, that's a distribution. Yeah, if you are correct. So before we do anything else, we need to distribute that 8. So 8 times y is 8y. 8 times positive 2 is plus 16. Equals 10y plus 16. This is okay. I know why this example is in here. So let's say that we want to get the variable to the right side. All right. So if I'm going to get the variable to the right, that means this 8y has to move to this side. That 16 has to move to this side. Now I want to show you what happens if you move the variable, or the constant first. So if I'm trying to get this y by itself, I need to subtract this 16. I'm subtract 16 from that side, 16 from that side. That goes to 0. That goes to 0. And then we get 8y equals 10. And the reaction I normally get from this is, now what? All right, so since this is something we don't see very often, it tends to throw people off. All right, and so because those constants were the same on both sides and canceled out, that's, this is the one time where I think this is why I like to move my variable terms first. So I'm going to come back to this. Because it's easier to explain what we do next if we do it the other way first. All right, so let's start with I'm going to start back after we already distributed. So we have 8y plus 16 equals 10y plus 16. Okay. So we're still trying to get the variable to the right. So we're going to subtract 8y from both sides. Now, and remember, if this was like negative 8y, then we'd be adding 8y to both sides. So adding, subtract, always do the opposite, adding, subtracting when you're moving everything across. So now we get 16 equals 2y plus 16. Okay, so now we're trying to get the y by itself. So we need to move 16 next. That goes to 0, that goes to 0. Now here's where you have to be careful, is we don't normally put that 0 on the next line, but on this left-hand side, there is nothing left. So we have to have something on both sides. So you have to have that 0 basically as your placeholder. Right? You can't just lose, half the equation. Okay. Now we have 2 times y, so opposite of multiplying by 2 is dividing by 2. And as we've discussed before, 0 divided by 2 is 0. Our answer is 0. Okay. Now, back up here. So what do we do from there? Well, if you're trying to isolate the variable, that means you need the variable on the same side. So if we're getting it to the right, what do? Well, we need to move this 8y over. So we're going to subtract 8y. So that goes to 0. Get 0 equals 2y. So we're right back to where we were before. It's just at this point, I see people doing all sorts of weird stuff like dividing by 8 or dividing by 10. That puts a 1 in front of the y's. It doesn't move the y's over. Or they try to divide by y. But if you cancel your y out on this side, you're canceling on this side. It's just this tends to lead to all sorts of mistakes. So that's why I like to move my variables term first just to avoid this. But as long as those constants are different, you don't have to worry about this little situation. Okay, and again, we can always check this. So if we take 0 and plug it back in here, 0 plus 2 is 2. 2 times 8 is 16. We plug in 0 there, 10 times y is 0. So 0 plus 16 is 16. So we get 16 on both sides. All right, so it is perfectly valid to get an answer of 0. All right. So let's see, 24 on here is pretty much the same thing. So I think what I would do now is let me go to the homework and pull maybe some messier ones from the homework. There's some different ones from the homework. Give you a little bit more directly applicable to the questions. All right, so in that multi-step homework equation, this is my question number 6. Solving 4 times x plus 1 in parentheses equals 6 times x minus 2 close parentheses minus 6. All right, so what do we do first? Well, before we can do anything, we have a distribution on that side. We have a distribution on this side. The left-hand side is pretty straightforward. 4 times x is 4x. 4 times positive 1 is plus 4. Now you have to be a little bit more careful on this right-hand side. So we're definitely distributing the 6 to the x minus 2. We do not distribute it to the negative 6 because that's not inside the parentheses. The only reason we would distribute it to that negative 6, the in parentheses would have to be outside the 6. So that 6 is just times of those two terms. So it gives us 6x, and then positive 2 times positive 6 up to negative 2 is minus 12. And you bring down your minus 6. Right? And again, we have like terms to combine. And so if we're on the same side, remember, do exactly what it says. Don't do opposite operations. Do the operations that are on that side. So minus 12 minus 6 minus 18. Now, technically, you don't have to do this, but often what I see students do is like they want to add 6 to get rid of here, and then they would add 6 here and add 6 here. So they would add 6 to all the numbers. If you do that, the problem is on this side, you added 6 twice, but on this side, you only added 6 once. So you didn't do the same thing to both sides, and so that throws off your equation. So by combining those two terms first, now, this is as basic as it's going to get before you can start isolating the variable. So you're just less likely to make mistakes if you do that first. All right, so let's get the variable to the left. So I want x equals. And so if I'm trying to get x equals, that means that 4 is going to have to move over. We're going to do something with that number. And that 6x has to come to this side. So I want both x's on the left. Right? That negative 18, that's going to stay over on that side. All right, so if I'm trying to get the variable on the left, first thing I'm going to do is subtract 6x. If you want, you could be subtracting 4. Doesn't really matter, big picture, which one you do first. Now, again, be careful with your negatives. 1 minus 6 is negative 2x plus 4. And over here, don't lose that negative. That is minus 18. So we get negative 2x plus 4 is negative 18. Now the messiness of this equation is over. Now we're back to like a core equation. So to get x by itself, subtract 4. And hopefully this is starting to feel a little bit more comfortable. So we have -2 times x. So remember, when you're multiplying and dividing, don't change the sign. So divide both sides by -2. So we get x equals 11. All right. So like I said, for the survey class, most of the time, most of the time we're going to be solving equations like this is in this homework. Later in the semester, we're doing more this level of equation. So that's sort of the messy equations, messy multi-step equations without fractions. Let's look at equations with fractions. Okay. Now, I'm going to back up and do a little bit more basic equation for fractions. But I want to just kind of throw this out here. One of the nice things about equations with fractions is you can actually get rid of the denominator by multiplying every term by the LCD. So hopefully you've done your fraction homework, so you remember getting LCDs for max subtracting. And so, when you have an equation like, say, 26 that has multiple fractions, you could deal with the fractions as fractions. If you're trying to isolate x by itself, you could subtract 2/3 over, and then you'd have that minus divide by 4 to deal with. And so theoretically, you could treat this exactly the same way we've done everything else. It's just you have to deal with fractions, which makes everything messy. So my suggestion is, once you get equations that have 2 or more fractions, is multiplied by the LCD, unless we get into portions, and these kind of have their own process. And that'll be a whole other video. All right, so let's back up and do a more basic equation before we try 26. Let's say I'm going to solve 3/4 x equals 5. All right, so in this case, we have just one fraction. And so that fraction is 3/4 times x. And so how do we solve for x? Well, our goal is to get x by itself. So that means we need to move 3/4 over. And how do we do that? Well, it's 3/4 times x. So what you could do is you could divide both sides by 3/4. So multiplying by 3/4 is dividing by 3/4. So what you do to one side, you got to do the other. Now this may look messy on this side, but 3/4 divided by 3/4 is 1. 1x, or just x. But now what? All right, how do we deal with 5 over 3/4? Well, if we're going to deal with this, one thing I would recommend is rewrite this divide by with this divide by. So take that fraction divide by, make it the divide by symbol. Now, how does that help? Well, how do you do a whole number divided by a fraction? Well, put your whole number over 1. And now, how do we divide fractions? You flip the divisor, make it a multiplication problem. That becomes 5 over 1 times 4/3. Then that's a multiply problem. That's 20 over 3. Nothing simplifies. And so we're done. So you could do it this way. But again, that in particular is a bit messy. So my suggestion on this is, up here at the start, we divided by a fraction. Well, what do we do every time we divide by a fraction? We have to invert it and multiply. So my suggestion on this, where this is one fraction in front of multiplied times your variable, and that's all you have on this side. Let's start with invert and multiply. And this only works if there's no adding or subtracting in the problem. If there's adding, subtracting in the problem, we can't do this step. We have to deal with it a little bit different, and that's what the other examples will be for. All right, so when I say invert and multiply, so instead of dividing by 3/4, I'm going to multiply both sides by 4/3. And again, the whole reason we're doing this is 4 divided by 4 is 1, 3 divided by 3 is 1. So that's still putting the 1 in front of the x. And what we do to one side, we have to do the other. So we're going to multiply both sides by 4/3. Again, let's put that over 1 to make it a fraction, easier to multiply. Over here we get x. Over here, we're right back to what we did before. And that's our answer. So if there's no adding, subtracting, and you have that fraction multiplied times your x, just start with your invert and multiply. That basically lets us bypass all of that right there. Because in the end, we're getting to the same exact process. Right. So that is like the more and this could be a whole number of fraction on this side, it doesn't really matter. If it's a fraction, then we wouldn't have to worry about putting it over 1, and then we would just multiply whatever fractions we have. But again, no adding, subtracting. This is sort of like the basic equation with fractions. All right, what happens if we have an equation that has multiple fractions? All right, so 26. So we can solve 2/3 over x minus 4 equals 1/12. All right. So one nice thing about equations with fractions is you can actually get rid of the denominator, whereas that was just like an abstract, and there was no equation here. You can't get rid of the denominators. They're there no matter what. But what we can do here is let's find the LCD. Okay, and so remember, the LCD is the smallest term that all the denominators will divide into. So anytime you're looking for your LCD, always start with your biggest one. It's either that or it's something bigger. Now 3 goes into 12, 4 goes into 12. So in this case, 12 is our LCD. And so what we're going to do with this, and I've got this in the notes, is we can clear the denominator by multiplying every term by the LCD. And the reason I highlighted every is it doesn't matter if it's a fraction or not. You have to multiply it by the LCD. So when we do number 28, that 9 also has to get multiplied by the LCD. All right, so if we do this correctly, what should happen is all our fractions should go away. All right, and so since these are fractions, I'm going to multiply by 12 over 1, not just 12. It might get a little messy here, but now what we're going to do is we're going to simplify. You can either multiply first, then simplify. I like to simplify first, then multiply, but either way. So 3 will go to 12 4 times. So then we have 4 times 2 over 1. So that gives us 8. Minus. Now 4 will go into 12 3 times. So we have 3 times x. So we get minus 3x. And then on the right-hand side, well, we have 12 over 12, which is just 1. So we get 1 times 1. So we get 8 minus 3x equals 1. And so if you've done this correctly, we should have no denominators. They should all, simplify out to 1. Now, we've talked about this before. You don't have, if you find a common denominator that would work. So like if you said the common denominator was 3 times 4 times 12, just multiply them all together. That will still kind of give you the no fractions part, just these numbers will be bigger. And so you'd have to simplify more at like the very last step. But at this point, now we're right back to a basic equation. So we subtract 8 from both sides. And that goes to 0, don't lose that negative. So that is the minus 3x or negative 3x. That's equal to negative 7. Then our last step is divide by that negative 3. X equals negative by negative is positive. And again, don't go to decimals, don't go to mixed numbers. Just keep that as a simplified fraction. It doesn't matter if it's improper or proper, just whatever it comes out to be. So that is the process of clearing the denominator. We multiply every single term by the denominator. So how about number 28? that I mentioned earlier. We have x over 3 minus x over 4 equals 9. Okay, so here we have a couple of fractions. And so let's clear the denominator again for good practice. And so again, it's probably helpful to put that over 1, so think of everything as a fraction. So what is the least common denominator? Well, start with the biggest one, 4. 3 does not go into 4, so we have to go big. Right, so if you do your multiples of 4, your multiples of 3, and 12 is the LCD. It's the smallest one that they have in common. Or if you did 3 times 4, you'd also get 12. And since they have no factors in common, that's why it's the smallest number. Like I said, when in doubt, you can always multiply your denominators. So it just so happens that we have 12 again. So what do we do with that 12? Well, now we multiply every single term by 12. Or 12 over 1 when it's a fraction. Okay, and then we're going to simplify. So 3 will go into 12 4 times. So that gives me 4x. Over here, 4 will go into 4 once, 12 3 times. We have minus x times 3, so minus 3x. Over here, we have 9 times 12, 108. Yep, 108 over 1, or just 108. Okay. So by multiplying everything by the LCD, we've cleared the fractions, or cleared the denominators. Now what do we do? All right, well, again, those are on the same side, so don't do opposite operations. Do whatever, if it's on the same side, do the operation that is there. And so we just do 4x minus 3x. This is 1x equals 108. And then once we get down to 1x, we have our answer. So this one might have looked a little bit intimidating because of the fractions, but once we got rid of the fractions, it wasn't near as bad as some of the others. All right, let's just mention number 20, like 27, like how we would get started. I think we've got the idea down, hopefully. If not, we can, you can always email me, go over this again. Or you can rewatch the videos, or MathLab has its examples. I've also got the videos from the book in Blackboard as well. But what's the LCD for this equation? And again, when we look at this, look at the entire equation at once. So start with the biggest denominator, 10. 9 does not go into 10. So what is the smallest number that both 9 and 10 will go into? Well, you go through there, they don't have any factors in common, so it's going to be 90. So then you're going to have to multiply every single term by 90, or since they're all fractions, by 90 over 1. And then you're back to what we've been doing. All right. Now, I'm just going to briefly mention proportions, but I have a whole nother video on that coming up. I do want to point out, the difference between a proportion versus, that's still 6.2, by the way. The difference between proportions and these equations with fractions. If you notice up here, we had, add, subtract, we had add, subtract, so here we had like, 2 fractions on one side. A proportion is specifically a fraction equals a fraction. So it's sort of like a very specific type of equation that has fractions. Okay, so there's no adding, subtracting going on, just fraction equals fraction. All right. And I'll just mention it now. Like I said, I'll do a whole other video on this. I don't want to get this, I'll keep this video shorter. Is you start with your cross products. Once you do your cross products, that takes care of the fractions. You don't have to worry about the whole LCD thing because the cross product is a different way to approach it. But we can't use cross products up here because of the fact that there's 2 fractions or 2 terms on a side. All right. So looking at the homework, there's some of these that have decimals in them towards the end. Let me do one of those. All right, so this is my number 16 from the homework. Again, your number 16 will look similar, but the numbers are always different because of MATLAB's random number generator. Go down and top. All right, so this is 0.16 times 24 plus 0.04x equals 0.08 times 12 plus x. All right, so if you ever are reading up stuff like this and they talk about like multiplying by 100 or 1,000 or whatever to get rid of the decimals, that is something you could do, but honestly, just treat the decimals like whole numbers, and then the only difference is, you know, use this to help you with the decimals, but I wouldn't recommend trying to get rid of the decimals first, because that can just get messy. It's sort of like clearing the denominator with fractions. It's just, particularly if it's something like this, there's a lot of places, more places I think you can mess up. So let's just deal with the decimals as decimals. So how do we start? Well, if you look on that left-hand side, we get two numbers that we can multiply, so do that first. Again, this is a calculator question. So 0.16 times 24 is 3.84. We have 3.84 plus 0.04x equals. Okay, and now what do we do on that right-hand side? Well, that is a distribution problem because we have a number outside that parentheses with two things in it. So we're going to do 0.8 times both of those. 0.08. 0.08 times 12 is 0.96. And 0.08 times x is plus 0.08. All right. So again, if there's something to do on one side of the equation or the other, do that before you start isolating your variable. Okay. And so if there's a number and a variable term, now we can start isolating. All right, so again, I think most people are going to get the variable to the left. So let's get the variable on the left-hand side, which means that 3.84 is going to have to move. We're going to do something with that number in front of the x. And this 0.08x is going to have to move over here. That 0.96, staying on that side. It's already on the opposite side of the x. All right. So again, I like to move my variable terms first. You can move your 3.84 first if you want. But to get rid of my variable on the side, I'm going to subtract 0.08x. 0, 4. Now that's a minus 0.04x. And again, when it comes to decimals, don't be bashful about grabbing a calculator. I do it all the time. All right. So now we've got all the variables on the left. Now we need to get the 3.84 over. It's plus 3.84, so we're going to subtract it. Yeah, don't lose that negative sign. So negative 0.04x is equal to 0.96 minus 3.84, which is negative 2.88. All right, so now we're back to that common last step. We have a number times the variable. So we're going to divide both sides by that number. In this case, we're dividing by negative 0.04. That gives us 1x and just x. And negative divided negative is positive. And 2.88 divided by 0.04 is 72. So just because we start an equation fractions doesn't mean the answer has to be fraction. It could be whole number. In this instance, we started an equation with decimals. Could have been a decimal answer, but it's a whole number. If when you're solving a problem like this, if your decimal number goes on forever, like all the way to, like the 9 or 10 places your calculator shows you, a good indication that something is wrong is if you look at the instructions in MATLAB. Share that. Okay, so if you notice down here in the answer, again, that part B and C, the all real numbers or no solution, we're not doing those. So it says simplify your answer. So if you get an answer that is a decimal number that goes on forever, if that was what they were looking for, they would mention something here about rounding. If your decimal answer is more than like 2 or 3 places, MATLAB is going to want you to round it. Okay. So just watch out for that. All right. Now, the last problem, I kind of threw that in here just to kind of warm you up because we are going to be doing word problems all the semester. So this is a little bit more of definitely more of an algebra question. But if you're throwing one at you in the homework, this is sort of what I refer to as like stretch your muscle questions. And so let's translate this. Okay. And so if 1 is added to 4 times a number, the result is equal to. Right, so as soon as I see that result is equal to, that tells me that this 1 is added to 4 times the number is the left-hand side, and then is equal to, so on the right-hand side is 7 more than 3 times the number. So we're going to find the number. All right, now I deliberately picked one where you have to identify the right equation first. So that way, because if you get this set up wrong, you can't get the right answer. So that's why this is here, because this is more just, like I said, extra skill. So if 1 is added to 4 times a number, so this is multiple choice, 1 is added, all right? So it can't be A or C, because that is 1 times, that's 1 times. So those are off. And so is it 4x plus 1, 4x plus 1, or 4 parentheses x plus 1? Well, what is 1 added to? It's added to 4 times the number. This is added to the number. So it either has to be D or B based on the left-hand side. Now for the right-hand side, which one is it? Is equal to 7 more than 3 times the number. Well, 3 times the number is 3x. They both have 3x. So are we multiplying by 7 or adding 7? Well, that 7 more says we are adding 7. So B would be the correct answer. That is how you set up that equation. And then you check it, and then it's going to say the number is, and so then you just solve that equation that you just chose. And that's an equation that we've solved before. All right, so don't worry, we're not going to see a lot of this. We're going to have other word problems that we'll deal with. This is, again, one of those more college algebra type equations. All right, so hopefully this helped. This concludes the multi-step equation portion of the 6.2 section. And so the last thing from 6.2 for the next video will be proportions. Have a good day.